This is lesson 5 of volume pyramids and cones, which can be found in the total surface area and volume topic. The learning goal for this one is to look into the formulas of finding the volume of pyramids and cones, and the success criteria for this one is to solve problems involving volume of right-angled pyramids and right-angled cones. By now, you should be used to the notion of getting the volume of a prism or a sphere of some sort by getting the area and multiplying it by its perpendicular height. When it comes to pyramids and cones, the formula is given as follows, and it looks very familiar to a normal prism and cylinder, where you get the area, a flat area, multiplied by its perpendicular height. The only difference is you're multiplying this by a third, or you're getting a third of whatever that area is. Now there's heaps of proofs and maths behind it, but when it comes to pyramids, a pyramid's volume is always going to be 1/3 of that area and height if it were to be a prism. Now the math itself is quite genius, but it involves quite advanced year 11 and year 12 methods and specialist type of mathematics. So I'm not going to get into it. All you need to know is for a right squared pyramid, remember right square having a right angle from the base to the apex, you get your area, which is this flat area here, which is x times x, or x squared, multiply it by its perpendicular height, then get 1/3 of that. Same thing with a right cone or an oblique cone. Remember, oblique means slanted. The area of a circle, which is the flat surface here, is pi r squared. Multiply it by the perpendicular height and just get 1/3 of that. Same thing with an oblique cone. And all we're going to do is just use these two different formulas to help us solve these type of questions here. So we're going to look for the volume of this rectangular based pyramid rather, with 1.2 meters by 1.4 meters and a 1.3 height. So the volume, this is just 1/3 of the area times the height. Now this is just 1/3 of, what is this area? This is the flat area 1.2 times 1.4. So I'll put that in brackets just so it indicates that it's coming from that flat base area, 1.2 times 1.4, and then we just multiply this by its perpendicular height, 1.3. So if we were to calculate this amount into the calculator here, you gotta make sure that we're using the fraction button and putting 1/3 or 1/3. Don't put in 0.333 as a decimal. We want to keep it as accurate as we can, so we keep it in fraction form. You don't have to worry about the brackets in this case. I just put the brackets here to indicate that's where that base area came from. It's 1.2 times 1.4 times 1.3. So this here is 0.728. Now I believe it said 2 decimal places. Give the answer for part B correct to 2 decimal places. I wonder what's going on here. It should be for question A as well. That's a bit weird. I don't know what's going on there. Well, we'll just keep it as 0.728. And this is in cubic meters. In other words, this is saying that if for whatever reason we manage to get a cube that is tangible and you can adjust it, a cube that's 1 by 1 meters, just close to this is a 0.72, so maybe 3/4 of this should be, nearly 3/4 of this should be able to fit within this rectangular base pyramid size here. That's how I like to visualize it. Last example before you guys can start on the question. We're going to get the volume not area, volume of this one here. So again, 1/3 times the area times the height. Remember, the area is circular this time because we're dealing with a cone. So it's 1/3 times pi r squared times its height. So this is equal to times pi times the radius. Now be careful, It looks like the radius is 23 in this case, but this here is the diameter. This is the diameter because it's stretching from side to side. So to get the radius, this is 23 divided by 2. That will give us 11.5 millimeters as the radius. So you have to be careful with this. If it's giving you the full diameter, half it to get the radius. So this is 11.5 squared multiplied by its perpendicular height, 29. Oh, whoops, it disappeared. There we go. Let's go ahead and put this into the calculator. 1/3 multiplied by pi, so shift times 10x times 11.5 squared multiplied by 29. 4016.26. Just had to double check to make sure that was all correct. Yes, it is correct. So 4016.26 squared cubed millimeters. That's all there is to it, guys. Just follow a basic formula, or depending on what 3D pyramid that you get, whether it's rectangular or square based, or if it's a cone or oblique cone, and apply that accordingly. Until then, I'll see you in the next video. Tell you all.